this confidence interval for some given proportion P. So first of all, when you choose your simple random sample of size n from a large population that has some kind of unknown proportion, the confidence interval uses this following formula. You take your sample proportion plus or minus your margin of error. So the margin of error is calculated by using the z-score for the confidence interval. Oftentimes we use that confidence interval of 95. If you use 95, I believe the z-score is 1.96, plus or minus, that is. And then your sample proportion times the success, that is, times the failure divided by the sample size and then square root it. That's your margin of error. And so when we're talking about how we figure that out, how you're going to create that interval, that's how you're creating it, as you're going in either direction by that amount. Let's see. You can only use this interval when the numbers of success and failures are both at least 10, and your population is at least 10 times your sample. That was the little n less than or equal to, capital N is less than or equal to little n times 10, or you can say that your population is at least 10 times your sample. So when you do this confidence interval thing, there's a procedure, an algorithm that we use on a regular basis. It's 4 steps. We've been talking about this already. You're going to state something, you're going to plan something, you're going to do something, you're going to conclude. It's very formulaic. When you start out, you say, we want to find a 95% confidence interval for the true population, and whatever it is, P equals something of golf ball diameters or something like that. In step 2, you talk about the inference method that we're going to use. Right now, the phrase that we're using as of today is going to be, we're going to do a one sample confidence interval for the proportion. You have to make sure that you check your conditions. Is it a simple random sample? No matter what you do from now on, you're going to say we have a simple random sample. Just do it. And then you're going to see if your sample is normal. So remember, we're trying to do statistics on this stuff, so when you're doing this, you want to have an approximately normal sample or your population to be that way. And so we're going to show the NP greater than or equal to 10, the N1 minus P greater than or equal to 10, and then that our sample is 1/10 at most our population, or that the population is at least 10 times our sample for independence. And then after we do that, we actually do the math where we use that formula. And then in the conclusion was that memorized statement that we talked about yesterday, where we say we are 95% confident that the interval from blank to blank contains the true parameter of, and put the stuff in context. So this is the formula or the procedure that we're going to use on a regular basis. And in the next slide, we're going to do 2 examples like that. This is where a lot of writing comes into play, so get your pencils ready. You might want to use different colors. I'm going to do the 4 different steps, break it out, and then after that we'll talk about margin of error. In our first example, we have the Gallup Youth Survey asking a random sample of 439 U.S. teens ages 13 to 17 whether they thought young people should wait to have sex until marriage. Of the sample, 246 said yes, and then we're going to construct and interpret a 95% confidence interval for the proportion of all teens that would say yes if asked this question. So step 1. We want to find a 95% confidence interval for the true proportion of teens ages 13 to 17 who say they should wait to have sex until married. So this part was the state part. And the next part, the do part, or the plan part, excuse me, we will conduct a one sample Z interval for P. And we'll find out later that we have different kinds of tests other than just using something called a Z interval. We'll talk about that later when we do other things. But for right now, we're going to use the Z interval. So first of all, we say we have a simple random sample from a Gallup poll. This is talking about the independence part when we start talking about that. And let's find out if it's normal. So when we talk about if it's normal, we look at NP, bless you, is greater or equal to 10, and N1 minus P is greater than or equal to 10. So when we look at the proportion, although I'm not going to write this down, when you think about the P, remember the P is the success of what's going on. So in this case, you would have 246 divided by 439. That's our P. That makes sense to you guys? The success. But then you're going to multiply that by the sample, which is 439. So when you multiply 439 times 246 over 439, you just get 246 for your NP, which is greater than or equal to 10. And likewise, when you do the N times 1 minus P, the failure would be the remaining amount. So if you subtracted that, 439 minus 246, that's 193. 193. So 193, which is greater than or equal to 10 as well. So both of these check off, and now you know that you have something that's approximately normal. You should also say, I'm sure, that the total number teens 13 to 17 is greater than or equal to 10 times, was it 439? 439. So that's good. So now you're done with that part. And again, this was the plan. And then the next part is the do. And in the do part, that's where you take your p hat, which is your sample proportion, plus or minus the z-score times the square root of p times 1 minus p all divided by n. Okay, so our p hat was whatever 246 divided by 439 is. So I get roughly 0.56 plus or minus the z-score for a 95% confidence interval, which is 1.96, which I mentioned on the previous slide, times the square root of the two proportions times each other, success of 0.56 times the failure of 0.44 divided by the sample size of 439, was it? 439. And so this gives us a confidence interval, if we look at it, that ranges for our confidence interval from 0.514 to 0.606. So this is the math part of it, the do. And then the conclusion part, which I don't really have a ton of.
Is that second number?
So the second number is 0.606. So the conclusion part is where you put everything into context. You do that memorize phrase that we had on the previous slide. So if you look back here, you say down below here in the pink, we are 95% confident. So for your conclusion, which I'm not going to have space to write, we are 95% confident that the interval from 0.514 to 0.606 contains the true proportion of 13 to 17-year-olds who say that we should wait until marriage to have sex. That's the conclusion. So really you're only doing two numbers in there, and you're just putting the beginning statement of what they were talking about in your conclusion. We are 95% confident that the interval from 0.514 to 0.606 contains the true proportion of teens from 13 to 17 who would say we should wait until marriage to have sex. Okay, in this next one, according to an article in the San Gabriel Valley Tribune in 2003, most people are kissing the right way. I don't know what Bart's deal was, but he's really into this touchy-feely stuff. It's kind of strange. That is, according to this study, the majority of couples tilt their heads to the right when kissing. Okay? You probably could have figured that out anyways. In this study, a researcher observed a random sample of 124 couples kissing in various public places. They found that 83 out of the 124, or 66.9%, tilted to the right. Construct and interpret a 99%, they went with 99% confidence interval for the proportion of all couples who tilt their heads